everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve the given differential equation. So let's get going. Problem solve. 3 into dy by dx plus 2y by 1 plus x equals to x cubed by y square. Solution. Given differential equation. Three into dy by dx plus 2y by 1 plus x equals to x cubed by y square. Now, we'll make the quotient of dy by dx to 1. For that purpose, we have to eliminate 3 from the first term. Okay, so what we'll do is we'll simply divide the whole equation with 3, or we'll multiply our LHS and RHS with 1 by 3, or we'll divide both sides of the equation with 3. Okay, then we'll get dy by dx plus 2y by 3 times 1 plus x equals to x cubed by 3y square. We can write directly like this, or we can either multiply both sides of the equation with 1 by 3 or divide both sides of the equation with 3. Let's see what happens if we multiply both sides of the equation with 1 by 3. Then we'll get 1 by 3, that is 1 by 3 into 3 is 3 by 3 into dy by dx plus 2y by 1 plus x into 1 by 3 is 2y by 3 into or 3 times 1 plus x equals to x cubed by 3y square. So here 3 gets cancelled and you'll get the same equation. Now we can write the above equation as dy by dx plus function of x into y equals to x cubed by 3 into 1 by y square. Simply I am separating function of x and function of y, okay, which is a Bernoulli's equation in y. We know that Bernoulli's equation is of the form dy by dx plus p into y equals to q into y power n, where p and q are either functions of x alone or constants, and n is a real number such that n not equals to 0 and n not equals to 1, right? So if you notice, you're having dy by dx plus some function in x into function in y equals to function in x into function in y, right? We can write this function in y as y power minus 2, right? Since y power minus n can be written as 1 by y power n. Okay. So by comparing these two equations, we can say that by comparing these two, we are having here n equals to minus 2, right? And also dy by dx plus some function of x into y equals to function of x into y power n. We can say that this is a Bernoulli's equation in y and x, okay, which is Bernoulli's equation. Again, by comparing these two equations, we'll get P, Q and N. So we have reduced the given equation to Bernoulli's equation. Again, by comparing the reduced equation with Bernoulli's form, we'll get P and Q, where P equals to 2 by 3 times 1 plus x, and Q equals to x cubed by 3. Again, by comparing y power minus 2 with y power n, you'll get n equals to minus 2, right? We should not get n is equals to 0 or 1. Okay, here we got n equals to minus 2, which is a real number. And P and Q are functions of x. See, here we have variable x and we don't have any other variable other than x, right? So we call these two as functions of x alone. Now what we have to do is we have to reduce this equation or this equation to linear form. Okay. Since we know that the standard form of linear equation in y is dy by dx plus p into y equals to q, where p and q are either functions of x alone or constants, right? So if you notice these two equations, we have dy by dx, so we'll just compare the Bernoulli's equation with the linear equation. LHS will be same, but in the RHS you're having function of x into function of y. But coming to linear equation, you have either function of x alone or a constant, right? You may get either function of x alone or a constant, but not the function of y, right? But here we are having the function of y. So what we'll do is we'll simply eliminate this function of y from the Bernoulli's equation to reduce this to linear form. Okay. So let's consider the first equation. Okay. Now we'll eliminate 1 by y square from the equation. So how we can eliminate 1 by y square from the equation? Simply you can take this y square to LHS, or you can multiply both sides of the equation with y square, or okay, only two ways. Either you can multiply both sides of the equation with y square, or you can take this y square to LHS part. So let's see what happens if we take y square to LHS. Then we'll get y square times the LHS part equals to x cubed by 3. Then y square into dy by dx plus 2 by 3 times 1 plus x into y square into y is y cubed equals to x cubed by 3. Okay, either you can write directly this step from this, or you can include one more step. Okay, fine. So let's see what happens if we multiply both sides of the equation with y square. Then we'll get y square gets cancelled, and then you'll get y square into dy by dx plus 2 by 3 times 1 plus x into y square, y cube equals to x cubed by 3. The same thing, So now we have eliminated 1 by y square from the RHS part. Now let y cube equals to some u. Now we have to differentiate on both sides with respect to x. So we can use the formula chain rule. Du by dx equals to, see here, this is a function of y. So this involves a differential dy in between. Now let's find derivative of u with respect to y. Since u equals to y cube, then derivative of, we'll just find the derivative of u with respect to y by differentiating both sides with respect to y. We'll get du by dy equals to derivative of y cube with respect to y is 3y square. Okay, now this becomes 3y square into dy by dx, right? Either you can find the derivative of u with respect to x like this, or we can just directly find. Now write the derivative of y cube with respect to y, that is 3y square into derivative of y with respect to x, dy by dx equals to derivative of u with respect to x. Okay, you can just write directly like this. You get the same thing. Okay, actually this is the formula. This comes from chain rule. Fine. We'll always prefer direct method instead of using chain rule, the lengthy process. So now coming to the first term, here you have y square into dy by dx, but we have 3y square times dy by dx equals to du by dx. In order to replace first term, we need to eliminate 3. So what we'll do is we'll take this 3 to RHS, then you'll get y square into dy by dx equals to 1 by 3 times du by dx, right? So when y cube equals to u, then y square into dy by dx equals to 1 by 3 times du by dx. Now the above equation becomes, replace first term by 1 by 3 times du by dx plus 2 by 3 into 1 by 1 plus x into replace y cube by u equals to x cube by 3, which is linear equation in u and x, right? The standard form of linear equation in u is du by dx in u and x is du by dx plus p into u equals to q, and the integrating factor of this equation is given by e power integral p dx, and general solution is given by u times integrating factor equals to integral q times integrating factor into dx plus c. Fine. Okay, so firstly, no, this is not a linear equation in u, okay? Since the quotient of du by dx is 1 by 3. Firstly, we have to eliminate 1 by 3 from this equation or from the first term, I can say, not from the equation. We have to make the quotient of du by dx to 1. For that purpose, we'll eliminate 1 by 3 simply by multiplying both sides of the equation with 3. Multiply both sides of the equation with 3. Then we'll get 3 times 1 by 3 into du by dx plus 2 by 3 into 1 by 1 plus x du equals to 3 times x cubed by 3. Then this becomes 3 into 1 by 3 into du by dx is 3 by 3 into du by dx plus 2 by 3 into 1 by 1 plus x into 3 is, okay, into u equals to, here 3 gets cancelled, then you'll get x cube. Here also 3 gets cancelled, then the reduced equation is du by dx plus 2 into 1 by x into u equals to x cube, which is a linear equation in u. See, the quotient of du by dx is 1 plus function of x into u equals to function of x. So we have reduced the given equation to linear form, that is standard form of linear equation in u. Now we need to find the general solution to the given equation. So the general solution to the reduced equation will be the general solution to the given equation, right? Now we'll find the general solution to this equation, which is the general solution to the given equation, which is linear in u. So by comparing these two equations, we'll get P and Q, where P equals to 2 by 1 plus x and Q equals to x cube, right? Here P and Q are functions of x alone, since it does not involve any other variable other than x. Now what we'll do is, we'll find integrating factor and then general solution. So integrating factor is given by e power integral p dx equals to e power, for p equals to 2 by 1 plus x into dx. Write the constant outside the integral, you'll get to integral 1 by 1 plus x into dx. Okay. Integral 1 by 1 plus x dx is log mod x, or you can just use integral 1 by ax plus b into dx, which is equals to 1 by a log ax plus b plus integral constant c, or you can use f dash of x by f of x into dx equals to log mod f of x plus c, or you can use substitution method. Let 1 plus x equals to t. Differentiate on both sides with respect to x, then we'll get 1 derivative of 1 with respect to x is 0 plus derivative of x with respect to x is 1 equals to derivative of t with respect to x, then we'll get 1 into dx is dx equals to dt. Okay, let's choose this, then this becomes, you can use any of these three formulae. Okay, you can choose any of these two formulae, or you can choose substitution method. For just compare integrand with this integrand, then you'll get, for a equals to 1, b equals to 1, you'll get 1 by 1 log x plus 1, simply log x plus 1. Or if you take f of x equals to 1 plus x, then f dash of x will be 0 plus 1, that is 1. Then 1 by f dash of x by f of x will be log mod f of x, or you can take this formula. Okay, you can choose any of these formulae. Then you get about 2 log 1 plus x. we don't write c here. Okay, here we are using integral, right? Then we'll get some integral constant, then you'll get e power some c, which is a number. Okay, instead of writing constant in every integral, we'll just write one constant finally in the general solution. So this equals to e. We know that m log n can be written as log n power m. Then you can write 2 log 1 plus x as log 1 plus x whole square. And also, since we know that e power log some function of x equals to function of x, e power log function of x equals to function of x, which is our integrating factor. So our integrating factor is 1 plus x whole square. Now we got the integrating factor. Now it's easy to find the general solution. The general solution to the given equation is given by u times integrating factor equals to integral q into integrating factor, that is 1 plus x whole square into dx plus c. We'll just use this formula, equals to integral x cube into x square 1 plus x whole square 1 plus x square plus 2x into dx plus c. This is equals to integral x cube into 1 is x cube plus x cube into x square is x power 5 plus x cube into 2x is 2x power 4 into dx plus c. Now we can split the integral. Integral x cube dx plus integral x power 5 dx plus integral 2x power 4 dx plus integral constant c. Then this becomes integral x cube dx plus integral x power 5 dx plus, here you're having constant 2, right? So let's write the constant outside the integral. You'll get 2 integral x power 4 dx plus c is equals to, since we know that integral x power n dx equals to x power n plus 1 by n plus 1 plus integral constant c, where n is not equals to minus 1. So here you are having n equals to 3, 5 and 4, which is not equals to minus 1. So we can apply this formula for all the 3 integrals, and we'll get x power 3 plus 1 by 3 plus 1, that is x power 4 by 4 plus x power 5 plus 1 by 5 plus 1, x power 6 by 6, right? Plus 2 into x power 4 plus 1 by 4 plus 1 plus integral constant c. This equals to x power 4 by 4 plus x power 6 by 6 plus 2 into x power 5 by 5 plus c. Now we can replace u. The next step, okay? The next step will replace u. Since u equals to y cube, so we are going to replace u, then we'll get y cube into 1 plus x whole square equals to x power 4 by 4 plus x power 6 by 6 plus 2 times x power 5 by 5 plus c. Or you can write this as y cube times 1 plus x whole square equals to 1 by 4 into x power 4 plus constant 1 by 6 into x power 6 plus 2 by 5 into x power 5 plus c, which is the required general solution. So this completes the problem. So we have seen a problem from Bernoulli's equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.